Hey everybody, now we're going to look at number 11, constructing an equilateral triangle and then bisecting one angle of equilateral triangle to construct a 30-degree angle. Now previously on page 32 of the workbook, number 7, you were asked to construct an equilateral triangle. So this is one that you've done before, and you did it by constructing a perpendicular bisector of a segment. Now there is an easier way to do it. I'm going to show you an easier way to do it. Yeah, if you constructed a perpendicular bisector of a segment, you just would have to select 2 points that were the same length as the segment away from the perpendicular bisector, thus constructing the equilateral triangle. I'll show you an easier way to do it though than number 7 was kind of getting at on page 32. So if I have a segment like length AB right here, I simply can copy that segment. How many times would I need to copy it? Well, just twice. Look at this. If I set my compass to this width right here, okay, I'm hoping that some people figured this out, that you can take this length here. This is length AB, and I drew a pretty big segment, so there we go. And it goes well. And then I could just draw an arc. This is all length AB away from point A. And then I could do the same arc, same radius that is, okay, radius AB, and I can do it again right here. And like, look at that. So that point is the same distance away from B as it is from A because my compass length didn't change. And because my compass length was set to length AB, if I connect to the top point, I have myself a nice equilateral triangle. Okay, so this is definitely one that you can figure out. And if you remembered page 32, number 7, you just had to construct a segment perpendicularly bisect it, and then take that length of the segment and then find a point that was that distance away on the perpendicular bisector from each endpoint. Okay, so anyways, we construct an equilateral triangle. Now we need to bisect one of the angles. So an equilateral triangle is made up of 3 60-degree angles as well. That's come up a couple times in our discussions because any triangle has 180 degrees total, and an equilateral triangle, all the angles are the same, right? It's a perfect kind of triangle where all 3 sides are the same, and it's equiangular because all 3 angles would also be the same. So 180 divided by 3 is 60. So now I just need to construct an angle bisector. Okay, remember, an angle bisector is a collection of points, and all those points are the same distance away from the sides of the angle. So if I swing a compass here, okay, and find the same distance here, and same distance here, and then I do it again in the middle, I would have found a point that's the same distance away from the sides of angle A. So this point right here, because I sort of didn't change my compass, I went whoop, I went whoop, whoop. Okay, I didn't change my compass the whole time. I sort of found this point that's not in either direction, closer to AB or closer to AC, let's call it. Thus, it must be on the angle bisector of angle A. So if I draw this on through, I get a 32 30-degree angles. Right there and right there. Okay, so there is your construction. I have my equilateral triangle right here. And I bisected one of the angles, no longer 2 60-degree angles. I have a 30-degree angle here and then another 30-degree angle there. I could use a compass to check my work if I wanted to, or some patty paper and copying and verifying those 2 angles are indeed congruent, but that does look like I bisected angle A. Let me know if you have any questions.